The next thing I'd like to talk to you about is how a matrix is used in our everyday life and how we could use that kind of mathematics to kind of do some nice kind of everyday things. This is a topic that occurs near the end of our college algebra course, and we always catch a little of this, you know, I'm never going to use this. Well, I'm going to show you a nice example today where you could use it. You may not, but you could use it if you needed to. And I've got to do some background on this. You know, what is a matrix? It sounds like a cheesy science fiction movie. What is the matrix or something? But, you know, the math stuff's not near as exciting as that movie. I'm just talking about a rectangular set of values. That's it. So anything that appears like that, you know, computer scientists call it an array. But if we can take a set of values, put them into a rectangle, I call that a matrix. And I'll give you an example of one. Kind of how they look. Let's flash this up. This is what I would consider a matrix. Okay, this particular matrix has 3 rows. A row here, a row there, and a row there. It has 4 columns. 2, 3, and 4. And so we call this, we always do rows first, a 3 by 4 matrix. Okay, that gives me reference then to the number of rows and then the number of columns. Okay, and that mix of numbers will become important as we start to kind of manipulate these things. We can add and subtract matrices in a very obvious way. The obvious way is that I just take things in the same locations and I add them up. So the 0 plus the 5, the 1 plus the 0, and so on. And you start, in this case we started with a 2 by 3 matrix. We have to add to a 2 by 3 matrix or else it's not defined, and we end up with a 2 by 3 matrix. Subtraction is exactly the same. If I subtract things in the like positions. So 0 minus 5, 1 minus 0, in this position 2 minus 2, and then just carry out that arithmetic as well. So adding and subtracting is not going to change the dimensions of the matrix. It started with 2 by 3, I end with 2 by 3. Okay? We can multiply a real number, or what's sometimes called a scalar, times a matrix in a real obvious way. If I say something like 3 times this matrix, well, just go through each and every term and multiply by 3. I mean, that's what I would do if nobody told me what to do. I'd say, well, this makes sense. And then just do the arithmetic, and you end up with the same dimension matrix when you're done. Okay? Now the real operation that I want to get to though is multiplying a matrix times another matrix. And this is very important. The dimensions have to be correct. In this case, I've started with a 3 by 2 matrix. I'm going to multiply this times a 2 by 3 matrix. Now, what has to happen, this number and this number have to match up. They have to be the same number, or else you cannot do matrix multiplication with these 2 matrices. What you end up with will be this by this. It will be, in this case, 3 by 3. So here's the way you do it. I'm going to flash it up. Don't lose your mind here, because this looks messy, but I'm going to walk you through it. Okay, this is the product of the 2 matrices, and here's how I get the entries. To get this first entry, I go up to the first row in the first matrix and the first column in the second matrix. And I say, okay, 3 times 1 plus 1 times 2, and that gives me that first entry. To get the second entry in the first row, second column, I get the first row in the first matrix and the second column in the second matrix. And 3 times 0 plus 1 times 1, and that gives you that entry. Okay? If I change tacks and I go down here, this is in the second row, first column. So second row of the first matrix and first column of the second matrix. And I just pull that little stunt. Negative 2 times 1 plus a negative 2 times 2. That gives me that entry. Okay? And you just do all that, do the arithmetic, and it gives you that answer. Now, it's not a hard trick. It could be a messy trick, but it's not a hard trick. Now, the question is, well, what is that telling me? I mean, you know, dandy, I can do it. I can learn to do it, but how is that useful to me? Well, let me give you an example. Let's say that you're a restaurant manager, you're a chef, you're a kitchen manager, something like this, and you mass produce food. So you have actually learned exactly how much of each of these resources you need for several of the items on your menu. For white cake, you need 2 2/3 stick of butter, 4 cups of flour, 4 eggs, and 2 cups of milk, for example. And the eggs, you probably don't use the yolks because it's white cake. See, I know cooking. Coffee cake, you have this mix of things. Sugar cookies, you have this mix of things. Bread, you have this mix of things. Now, what I can do is, this is a matrix in a way. It's just stated in table form. What I can do is peel all this other stuff off and just keep the numbers in that rectangular form, which is what I've done. Okay, and I can go back and show you, but those numbers match up exactly with the numbers I had before. All right. Now let's say that you go through and you know how much each of these items cost. For example, butter is 50 cents a stick, flour is 30 cents per cup, and so on. Well, you can put this information into a 4x1 matrix. Now that would have 4 rows and just 1 column. So here's the 50 cents, here's the 30 cents for the flour. And you have to be consistent, you have to do things in the same order, and you have to use the same units of measure, which I'm doing here. Okay? Now, what do I get if I look at A times C? Okay, and this is going to be matrix multiplication. This is a matrix, it's just a 1-column matrix. Well, if I multiply these things, let me write it out. I would say 2/3 times this, 4 times this, 4 times that, and 4 times that. Add all that up to get the first entry. Well, what this is telling me is the cost of the items for that first thing. What was it, white cake? This is how much the produce will cost me for a white cake. And then I go through and do this again for the coffee cake and so on. And I'll spare you the gory details, but you just get this, you get these prices then. That's the amount of produce that has to go into, I don't know if produce is right, but the goods that go into making these different items. And you've got that instantly. And the cool thing is that, all right, and that's white cake, coffee cake, sugar cookies, and bread, because I forgot what order they came in. Now, the cool thing about this is if there's a change in price, okay, this is where it's really useful. All they have to do is go through and change that C matrix. Okay, so what was that, flour? No, that was milk maybe, I forget. If that goes up and this goes up, you just change that one matrix and then you multiply them again, and all of these totals change instantly. Okay, so this gives us a very slick way to recalculate the cost of things without having to go through and do a bunch of tedious calculations. You know, and maybe that seemed tedious to you, but what I would advocate is, look, these graphing calculators that we're all using can do matrix multiplication. Plug them in there, go for it, pop out the answer for you. Again, I'm going to summarize what I just talked about in a few slides, and I'll take a small break and get set up for the next segment.